Our presentation topic is the variables which affect the attendance of the baseball game. Our team member I'd like to introduce Hwa-shin, Jong-yeom Kim, and my name is Seung-kyun Hwang. We tried to see what factors explained the attendance of the baseball game. Originally, we tried to collect the U.S. Major League data. However, collecting data is not easy for us because of a lack of knowledge about the U.S. Baseball League. We quickly changed to Korea baseball game that we are accustomed to. We collect a bunch of data that could affect to the attendance with a reasonable guess, such as the population, weather, and other data we collect. Among them, our interest factor is the number of the star players per game. In other variables, we consider the day of the week from Tuesday to Sunday. Based on Saturday, we set the other days as an indicator. We included the winning percentage, the population, and the temperature as a quantitative variable. And additionally, we also see the night game as a category variable. The first thing we did is simply learn the regression with all variables. And then we run our program for making correlation metrics of each variable. We found the variables, the winning ratio, home and away game are highly correlated. Next part will be Hwa-shin explain about other stuff.
And we from our last PPT, we found that WPD and WPH has the very close relationship, so we want to choose one of them, and we use regression model to choose. First we choose WPD, and from this PPT we can see that the adjusted R square is 0.2827. And next we choose WPH as our parameter, and from this PPT we can see that the adjusted R square is 0.325. And from our analysis, WPH, the R square is bigger than the WPD, so we choose WPH, and then we use ANOVA table to get our final design. And from this map we can see that WPD, the R square is, the SSR is smaller than WPH. You know that SSR, the bigger the better, so we choose WPH instead of WPD as our final design. Then we use stepwise to select the parameter which is more suitable for our model. From this we can see that we select 7 parameter, and first is Friday, second is popular, divided by 10,000, and star player, Thursday, Tuesday, Wednesday, WPH. And then this is model from our stepwise procedure. And from this model, we can see that we choose 7 parameters. Friday, population, dot 2000, star player, Thursday, Tuesday, Wednesday, WPH. And our adjusted R-square is 0.3299, and our p-value is smaller than 0.05. And this means that this model fits our data better than the last one. And
Okay, hi, my name is Jongkyung Kim. You can call me JK. Let me explain the last part of our presentation. After we got the model from this stepwise procedure, we draw a scatter plot matrix to see whether there are some patterns among the variables. As we learned from the lectures, by looking at the scatter plot matrix, we can see we can get more information about whether there are some problems in our model, or whether there are some ways we can improve our model. So we draw this matrix and looked and found some patterns between the variables, between the residuals and between residuals and explanatory variables. As you can see, the population and the top layer is showing some patterns. So we decided to add some complex terms of variables, which are interaction terms and quadratic terms. So we added the interaction terms between Friday and population, and Friday and star player, and Friday and WP, and the quadratic term of population and the star players and WPH. So including these some quadratic terms and interaction terms, we regressed the attendance on all these variables, and fortunately we can see that adjusted R-square increased significantly, from 0.3299 from the in the last model. The adjusted R-square of this model is 0.4365, and p-value is very, very small. So this, we can see this model is very useful. But we didn't finish here. We did the stepwise model selection procedure again, and we finally get our model. We got our final model, and there are only nine variables left. Interaction term of Friday and WP, and the population, and the quadratic term of top layer and Tuesday, Thursday, Wednesday, and WP, quadratic term of WP and WPH. It is not so surprising that Friday and Sunday are deleted, because our base is the Saturday. So usually the Friday, Saturday, and Sundays are regarded as weekend, so they are similar. So Friday and Sunday are removed, and you can see the adjusted R-square a little bit increased to 0.4412, and the p-value is also very, very small. So it's this indicates that our model is very useful to explain the attendance of the baseball games. Okay, so our conclusion is that our final model is very useful based on the F-test, based on the results of F-test and adjusted R-scale and T-test. As you can see, F-test, the F value is significantly F value is significantly bigger than the benchmark of F value, and the adjusted R-scale is 0.4412, which is pretty high, and T-test results indicate that our model is also very useful. And let me summarize what we have done for this paper. We first did regress attendance on all the variables, all the data we collected, and then checked the correlation and let me show you this. We regressed all the attendance with all the variables, and then we checked whether there are some variables which are highly correlated, and we found that WPH and WPD are highly correlated. So to remove one of them, we regress the attendance we did regression on the model with WPD, and the other one is model with WPH. And we, by doing the ANOVA analysis and by looking at the adjusted R-scale of those models, we decided to delete WPD. And then we did stepwise procedure, and then we checked the scatter plot matrix to see whether we need to add some quadratic or interaction patterns. And then because we found some patterns from this scatter plot, we added some more complex terms, and then we found that the adjusted R-scale increased a lot. And then we did stepwise again, and we got final results. One final model. Actually, we looked at some QQ plot or residual plot also as well, but we did, even though we didn't include those plots, graphs in this slide, those graphs indicate that the residuals are pretty normally distributed, so there's no serious problem in this model. So we conclude that the variables which affect the attendance of Korean baseball games is population and number of players, and whether it is weekend or weekdays, and winning percentage of home team. So yeah, this is our conclusion. That's it. Thank you very much for listening to our presentation.